just no use, can you build that muscle back, or does the cell die with atrophy?
It would depend on what the reason for the atrophy might be, okay? Now, say for example, the case of someone who's doing the weightlifting, and they build up the muscle, and then they decide to stop weightlifting, okay? That muscle will atrophy, but it won't be to a point that it couldn't be redone, okay? But let's say that the atrophy is due to a genetic disorder, okay? That's not going to come back. If it's due to bed rest, there's a chance, depending on how long it had been for the bed rest, and depending on if there was something done to make sure that the muscles continued movement, like if people came in and physically did the movement, that could build back up. Okay. If the person gets better, okay, and can begin to work on it on their own.
So they would need probably like a high protein diet?
Right. You would want to, yeah, because anytime you think about wanting to do the buildup of the muscle, because these filaments are proteins, okay, you don't want that diet stuff just simply going to that and nothing else. I mean, the cells have other stuff to do than just the muscle. That's why if you're, people who do want to build up their muscle, they really do need to increase their protein intake. Notice I said protein, not the fat.
Yeah, that's my question. I always get confused though with the elderly. It seems like even though they do the high protein drinks to help them, because you're talking about cellular respiration, it feels like there should be some carbohydrates in there.
Oh, you would still want them to get a proper amount of that for a diet, but you would want to focus more on proteins.
Okay.
Yeah. In the elderly, the issue that we're going to run into, okay, because, you guys, stuff's going to break down. Okay? I'm just letting y'all know that right now. Enjoy the youth while you have it. All right? Because stuff's going to break down. All right? One of the things that's going to break down is the ability for these fibers. Okay? Proteins are not going to be made as correct as they are at your age right now. Okay? And then other stuff's going to start breaking down. Your collagen and your elastin and all this other fun stuff. Okay? The mob wives. Some reality show. Okay, because it just made me think about this for some reason. So for the first time, on my Facebook page last night as I was scrolling through it, there was some news article. And the woman was kind of scary looking, And so it's like a train wreck. You don't want to see it, but you keep looking at it, okay? And so I'm like looking at this picture, and I mean, just huge, okay? And I'm like, what in the world? So I click on it to read the article. And, she's talking about how, she's left her husband or whatever or something like that. And, it's just good right now for her and her grandkid or whatever. I don't know, because I don't watch the show. Well, what was so funny is this morning, as I'm talking to my best friend coming to work, she's like, did you hear about that mob wife that died? I was like, huh, what? And I said, who? And she goes, well, she was, kind of unique looking. And I read an article about her last night. Well, during the night she died. She
big
had,
age?
Yeah, big age. She had lung cancer or something.
Yeah, she did have cancer.
And she
but that she was, that's sad.
And so, that is what happens, like, because I mentioned collagen, okay? That's what happens for people who get the collagen injections in their lips, okay? And see, here's the thing. As we get older, collagen is going to break down no matter what, okay? And the stuff that you get injected like that, okay, if you start out like that, eventually the lips do what? They go back down because the body can't absorb that collagen. It's just a filler. The body can't absorb it. Yeah, I don't know why, I just thought about that. Okay, so myoblast, all right? With the myoblast, like I said, what you get is what you got. The striated appearance, this banding, light and dark bands right here, that is going to come about based upon these protein filaments, okay? The protein filaments are going to overlap, and that overlapping gives us the banding appearance. That overlapping is going to become extremely important, okay? In the little video that we watched, do you remember the layers that were mentioned? Okay, epi, peri, endo. Connective tissue wrappings. The epimysium, do you remember it talking about how it ran continuous with the tendons that hold the muscle? Okay, so epimysium. Perimysium, that's going to be around a group of muscle fibers. So if I have muscle fiber, muscle fiber, muscle fiber, muscle fiber, muscle fiber, they're going to be held together by perimysium, and that, okay, group of those fibers, cells, one right after the other, is going to be termed a fascicle. All right? Endomysium is going to wrap the fibers. With muscle, remember how we were talking, I think yesterday, breaking up the fascia? Like the rolling on the rollers or whatever, okay? Muscle, due to its makeup, okay? And I think one of the one of the slides yesterday, I kind of showed you those compartments that are made up, okay? How we had like compartment after compartment after compartment, and we talked about the compartment syndrome, okay? That tissue, okay, is going to be like a sheet wrapping around, holding a group or a muscle together, okay, so that you would have a muscle, 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 and that connective tissue was a sheet, the fascia, all right? And so that's what kind of gets broken up at the time of like doing that rolling or the massaging or the really deep stuff that might get done, okay? That one, the fascia, is outside the epimysium. So the outer cover around the muscle, the fascia is found around it. It helps hold the muscle together and put it into functional groups. So yesterday, when we looked at the picture with the compartments, all right, we had compartment after compartment after compartment. That was muscles that would work together as a group. So you would have group after group after group. And remember, I mentioned that muscles work together in groups. Sharon?
Yes, I was just a bit confused. The epimysium surrounds like the whole big muscle.
Like
the
I would
whole
have, like if this were the muscle, because this is the sartorius muscle, okay? I have around it epimysium, but around that is going to be this sheet that would be the fascia, okay? And so the muscle laying next to here would have its fascia. The one laying next to this would have its fascia. Epimysium is only for this muscle.
Okay. And then within that, the fibers which are go to the cells are covered by the perimysium.
Right. So
inside.
if we could break this down, the epimysium would do that infolding around those muscle cells. So I would have a group of fibers, like fibers, and those would all be surrounded in a fascicle by the peri. And then if I look to that fascicle and I have fiber after fiber after fiber, each one of those would have endo around it.
Okay.
Okay? Sort of like this.
Okay.
Couple of things I want to point out. A muscle, okay, with the epimysium running continuous with the tendon, okay? Now, here's something I want you to look at. Let's follow here down to right here. What do you notice?
Blood supply.
Open area.
I have a blood supply, and whenever we see yellow, that's going to be representative of the nerve supply. For every muscle that you have, okay, each muscle that you're seeing in front of you, okay, it has that one huge nerve supply and vessel supply. Now, what do you note about the blood and the nerve supply once it's in, once it has entered into the muscle as a whole? It only has that one entry.
Kind of wraps around each.
It looks like capillaries go off of it to supply each little.
You
Fibers,
the nerve,
fibers,
you'll affect the
fibers.
blood
Touches every
supply.
fiber.
Branching.
Branching.
I have branching. And I get branching to every single fiber of the muscle. So I get branching from the nerve as well as from the blood supply. I think I kind of showed this once before. I'm trying not to lose all the little sticky things. Okay? These are the big vessels, and it would be the big nerves. Okay? The names we know. For example, if we've got the femoral artery, we've got the popliteal artery, if we've got the brachial artery. Do you see what I'm saying? The ones that we know the names for. That's the big one going into that muscle as a whole. Okay? Now, the blood vessels branch, and note, they branch to every single cell. But so does my nerve. So this is the nerve right here that we would know the name for. But once it enters into that muscle and begins branching and branching and branching and branching and branching, until it gets to the very terminal end, where that terminal end is going to meet that cell, okay? We don't have a name for that. Because at this point, it is so microscopic, there is no way we could name it. But every single fiber, every single cell has its nerve supply. This terminal end right here is our neuromuscular junction. Neuromuscular.
And there's one of those on each side, each end of the muscle fiber.
It only comes to one spot. So I could have a cell, a fiber this long, and so if I were to do that peel and hold it up like that, there's only one point that the end of that nerve